Welcome to our video for the mandatory Handin part 3. My name is Rick and in our group is Tasha and Lenka. We are making this video to see which model would be best to make the forecast for um, the daily energy consumption of Norway. As you can see here, we definitely have some seasonality in the data. In wintertime you use more energy than in summertime. So we can use this for our models as well, of course, that we have to use the models which conclude seasonality. Over here in the data we have the available data over here, the date and the day number, which we can use for our models. The first models we would use is the random walk. The random walk is pretty easy. You just use the latest available data or data for within the previous week. So that means if last Monday this was the energy consumption, then for next Monday this will be the energy consumption. Pretty straightforward, quick to use and very easy. For our next model we use moving average. The moving average takes up to 4 different kinds of data available and it will just get an average out of this. To do this, however, you need 4 or 5 previous data available. You can also do it by 2 or 3, that doesn't really matter, but you can use as much as available. For our model we just used 4 just to show it. As you can see here, it's C1 or C2, C9, C16 and C23, and then we're gonna pull an average out of this and then voila, you get your answer over here. Pretty straightforward and pretty easy, as you can see here. For the next one, exponential smoothing is a little bit more complicated. We use here alpha as a parameter. You can see it here. We don't know exactly what alpha optimal will be, but that using the solver it will check out which is the best value for this. The calculations over here, that means that it's the latest available data plus 1 minus alpha times the latest available forecast, which is also in here, which you use double. If you go all the way down, then you can see here that it is the latest. This is the equation. So to get the perfect equation, we use the mean absolute error to estimate the alpha. If you go over here, we just use the ABS over here. That is just basically the observation minus the forecast in absolute value. Then we can calculate the errors. So that means this is for random walk, moving average and exponential smoothing. For the mean absolute error, we divide it in 2 parts, in seasonality over here and out of seasonality over here. That is everything in 2017 and everything before this. Just to make sure and check if there are great difference between the models, or I mean between the sections. So if we go all the way down, we have a sample, in sample and out of sample, so you can see if there are a lot of difference in. But since there are a lot of available data, there will be always pretty much differences in the equations. So if we go to the calculations, you can see here the total mean absolute error in sample and out of sample, and it's just well, basically the average from all the available calculations. We use the exponential smoothing absolute error for estimating the alpha. We use the solver over here, press solve. Oops, next one, sorry. We use the solver, we click over here, use the solver, then use the available data over here, change it to the variables and select non-linear, click solve, and then we should have our estimated alpha would be 1. That means that that will be the best one for the calculations. If you can see here, this is the in and out of sample results. That means that the exponential smoothing model will be probably the best for our forecast because it has the lowest value, and the lowest value is the best value in this case. Alright, well, this was our film.